Hi all, this is Dr. K.G. Shanti, Professor, ECE Department, R.M.K College of Engineering and Technology. In this video, we are going to see orthogonal coordinate systems, which is the fundamental for understanding all the concepts of electromagnetic fields. Orthogonal coordinate systems. Any physical quantity in electromagnetics is going to be a function of space and time. Right, a point in the three-dimensional space is going to be located as a function of three surfaces. That is, it is going to be an intersection of three surfaces. Right, since the three surfaces are mutually perpendicular to each other, we call it as an orthogonal coordinate system. And when I say an orthogonal coordinate system, you will have coordinates and those coordinates are also mutually perpendicular to each other. The most commonly useful orthogonal coordinate systems are, first one is Cartesian or rectangular coordinate system, second one is circular or cylindrical coordinate system, and the third one is spherical coordinate system. Circular or cylindrical coordinate system. The three mutually perpendicular surfaces in the case of a cylindrical coordinate system are, first one is a cylinder of radius rho. So the orange color cylinder. Next is we have a plane, the yellow color one, we have a plane which makes an angle phi with the x-axis. So the yellow color plane. The third one is you have a plane with z constant, which means that from this line this height is going to be z. So any point P in cylindrical or circular coordinate system, the other name for it is an intersection of a cylinder, a plane with phi constant and a plane with z constant. Right. Now, what are the coordinates? What are the coordinate variables? Coordinate variables are going to be rho, phi and z. Right? What will be the range of the coordinate variables? Here what is rho? Rho is the radius of the cylinder, which means that it can vary from 0 to infinity. Radius can vary from 0 to infinity. What is the next one? Phi. What is phi? Phi is the angle which the vertical plane makes with the x-axis, which means that it can vary from 0 to 2 pi. Right, now what is this plane? Plane z. And this plane, this value of z can vary from minus infinity. It can be placed anywhere, right? It can be placed from anywhere between minus infinity to infinity, right? That's the range of z, okay? Right, any point P, as I told you, is going to be intersection of these three surfaces. Here I have numbered it as rho 1, phi 1 and z 1. See here, rho 1 is the radius of the cylinder. Now this is nothing but the vertical plane which makes an angle phi 1 with the x-axis, and you have a plane here. This one is plane which makes, what is the height here? From here till here it's going to be z. Now you have three unit vectors. What are the three unit vectors? Arrow in the direction of increasing radius of the cylinder. Then you have A phi. See here, this one. A phi is in the direction of increasing phi, and the last one is going to be AZ. The AZ is going to be in the direction of increasing Z. So any point P, see here, it is represented as rho 1, phi 1 and Z1. Now, how do you represent a vector? A vector A in cylindrical coordinates can be written as arrow into arrow. This is the component along rho direction, and this is the unit vector. A phi into A phi and AZ into AZ. Now, having seen how do you represent a vector in cylindrical coordinates, now we have to know the relationship, right? And this relationship is also going to be the same as in cylindrical coordinate, that is Cartesian coordinates. Arrow into arrow, a vector on itself, angle is 0, right? And this is dot product. So what it is? Cos 0. Cos 0 is going to be 1. So you have arrow dot arrow is 1, a phi dot a phi is 1, az into az, because vector upon itself, angle is 0, so cos 0 is 1. Here arrow into a phi, which means that they are perpendicular vectors, cos 90 is 0. So you have it as 0. Here arrow into a phi. Arrow into a phi is nothing but magnitude of arrow, magnitude of a phi into the sine of the angle between them. Sine of the angle between them is sine 90. And what is the normal vector? Az. So the same way a phi into az is arrow, az into arrow is a phi. Let us now look into how a differential element will look like in the cylindrical coordinate system. See here, for easily understanding, initially if z is the height where the one of the plane is there, I am including a distance dz, right? Dz is a differential element, right? It's a differential length. So dz, see here, this is going to be dz. Okay, right. Now initially the vertical plane is placed at an angle phi, this line, right? And I am giving a small increase in d phi, right? So this small variation is going to be d phi. Okay, right. Now see here, you all know length of arc method. What is length of arc? This is rho, even this is rho, and this angle is d phi. If that's the case, right? Now what is this length of arc? Fundamental mathematics, this length of arc is nothing but rho into d phi. That is what is written here, right? So generally in simple mathematics, if this side is A, this side is A, and if the angle between them is theta, then the length of the arc is nothing but A theta, right? The same way here. Now what is it? Now I'll show it in a different color line. So this curve, or this is going to be, what is this? It is going to be rho into d phi. Hope you're clear with that, right? So one more variation, say the distance of the cylinder, radius of the cylinder. See here, from here till here it is rho, and this additional variation, which I'll show it by some other color, this additional variation is nothing but d rho. So three elements: increase in radius d rho, increase in a variation in the height of horizontal plane dz, and then variation of the angle phi, which the vertical plane makes with the x-axis, right? This is going to be your x-axis, this is going to be your y-axis, and this is going to be your z-axis. Is that clear? See here, in this diagram, it is very clearly shown. D rho, dz, and what is this length of arc? This arc, and this arc, all this is going to be rho into d phi. Now let us look into the, having seen the various differential elements, now let us find out what is the differential length. Differential length is d rho into a rho, and the next differential length is going to be rho into d phi, right? Rho into d phi into a phi, dz into az. So we have seen what are the various three differential elements: d rho, rho d phi, dz, right? Now let us look into the differential surface areas. So for the a vector coming out from a surface, what are all its bounding elements? Rho d phi and dz. So what will be ds rho? It is nothing but rho d phi into dz. See here, rho d phi into dz. And what is the vector coming out from the surface? A rho. Look here, second one, d rho into dz, And what is the vector coming out from the surface? A phi. And here it is going to be third one, d rho into rho d phi, right? What is the vector coming out? Az. So that is what is dz. Okay. So these are the differential areas. Now coming on to differential volume. What will be differential volume? dV is equal to all the three sides, rho d phi, dz and d rho. Now, having looked into Cartesian and cylindrical coordinates, now this slide is going to give me the relationship between Cartesian variables and cylindrical variables. What are Cartesian variables? X, Y, Z. What are cylindrical variables? Rho, phi, Z. Now look at point P. If a point P is represented in X, Y, Z, now how will this point be represented in rho, phi, Z? How will I find out the equivalent of it, right? Now see here, this angle is phi. This distance from here till here it is x. This distance from here till here is rho, right? Now what will I do? Find out sine phi. When I find out sine phi, opposite by hypotenuse. What is the opposite? Right? Opposite is going to be y by rho, right? Or what will be y? Y is equal to rho sin phi. In the same way, you get the value for x. X is equal to rho into cos phi. Actually, you must have got cos phi is nothing but equal to x by rho, or x is nothing but rho into cos phi, right? And z, and now apply Pythagoras theorem. This is 90°. This is going to be x and y, right? So what will be rho? Rho is nothing but square root of x square plus y square. That is what is written here. And what is angle phi? Phi is nothing but tan inverse of opposite by adjacent. So tan inverse of phi by x. And what is z? Z is equal to z. The reverse. Reverse is, now when I look into this set of equations, what is the inference I get? Given x, y, z, how will I find out rho phi z? Right. The reverse. Given rho phi z, how will I find out x, y, z? What is x here? Very clearly from the diagram, x is nothing but rho cos phi. And what is y? Y is nothing but rho sin phi. And what is z? Z is equal to z.